Okay, so this time we are covering Unit 7A. This is just the very basics, the fundamentals of probability. Hopefully, you remember from high school some of your basic probability things. So, a couple things to do. There's really two kind of definitions you got to know. One of them is outcomes, and the second one is the event. All right, so if we toss if we toss two coins, then we will have four different ways that they can land. We can have heads and heads, heads and tails, tails and heads, or tails and tails. Those are known as the outcomes. Okay, it's a list of all the different ways that something can happen. The event is the number of heads or the number of tails. So in this case, there are four outcomes. There are three events. You can have no heads and two tails. You can have one heads and one tails, or you can have two heads. In the case of an outcome, the order does matter. It matters whether it's head first and then tails, or tails first and then heads. If it's an event, if we're listing the event, the order doesn't matter. We just care about whether it's heads or tails. One heads, one tails, doesn't matter which one comes first. Okay. All right. So, if we have a family and they have two children, what are the outcomes of the birth orders for boys or girls? So the outcomes, we can have boy, 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 girl, girl, boy, girl, girl, and whatever you write them down, the order does not matter. So there are four different outcomes. For events, there are three outcomes. You can have two boys, two girls, or one boy and one girl. Okay, and since we're dealing with event, it doesn't matter if the boy is born first or the girl is born first. Okay, it's the same event. All right, so we have a cat, we have a dog, and they are spinning to find out what to have for lunch. Dog's happy, cat, not so much. Okay, which leads us to what is fair. So if you flip a coin, fair means you have a 50-50 chance of landing on heads, you have a 50-50 chance of landing on tails. Okay, there are two outcomes. You get heads, you get tails. You've probably heard of weighted coins or weighted dice. Okay, if I flip a coin 10 times and I get 7 heads and 3 tails, I'm not really that concerned. It's a very small sample size. If I flip it 1,000 times and I get 700 heads and 300 tails, it's probably not a fair coin. Okay, it's been weighted sometime. Same thing with dice. Okay, if I roll a die, chances of getting a 1 is 1 out of 6. Chance of getting 2 is 1 out of 6, so on and so forth. You've probably seen them in TV shows or movies where somebody's rolling weighted dice. Okay, it makes it more likely that it's going to show up in a certain number or a certain combination of numbers. So that is what fair is. So obviously the little spinner for lunch with the cat and the dog is not fair. Obviously favors the dog more than the cat. All right, so when you're dealing with probability, the numbers, if you're going to convert these to a percent or a decimal, are going to be between 0 and 1. 0 means it's impossible for the event to happen. So if I'm rolling a dice, 1 through 6, and the question is, what's the chance of rolling a 10? Well, that's going to be 0 because there are no 10s on the dice. It cannot happen. If something is less than 50%, it's said to be unlikely to happen. 50-50, obviously, is half. Anything above 50% is likely, and anything the highest probability is 1 or 100%, and that means the thing must happen. So if I say, if I have a dice 1 through 6, what are the chances of rolling something less than 7? Well, all those numbers are less than 7, so it's going to be 100%. So if you get a number less than 0, if you get a number greater than 1, when you're dealing with probability, you've made a mistake somewhere. It's just kind of as simple as that. So probability of getting or something that has a probability of 1, the sun will come up tomorrow, got him a point. Probability has 0 is you will win Teacher of the Year. And kind of sarcastic teacher, he's not getting Student of the Month either. 0% chance of that happening now. All right, you've all gotten those questions. What's the probability of pulling a red marble out of a box or a green marble out of a box? Well, in this case, the probability is 0 because you're pulling out screws. Cannot happen, so therefore 0. Kid wants to go to Billy's party. Probability is 0. If you violate the probability, it's the same thing as dividing by 0. The universe will explode. And I can't believe it. What are the chances? If you remember, chances of something happening, it has to happen is 100%. So if it did happen, probability that it happened, 100%. Doesn't matter what the probability was before it. If it happens, it's 100%. All right, so there's 3 types of probability that we're going to talk about. The first one is probably the one that you're most experienced with, and that would be theoretical probability. So what you're going to do is you're going to count the total number of possible outcomes. That goes in the denominator. Then for the numerator, it's the possible ways of what you want to have happen goes in the numerator, and the probability is just one over the other. All right, so when you are doing these, I would recommend making a list. Lists are very nice when it comes to probability. So for 2A, what's the probability of getting 1 heads if you toss 2 coins? So we're going to make a little list. We have heads, 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 tails, tails, heads, and tails, tails. There are 4 different outcomes, so 4 is going to go in the denominator. There are 2 cases where you have exactly 1 heads. You can go heads and tails, or tails and then heads. So the 2 outcomes that are favorable goes in the numerator. 2 over 4 is 1/2. So if you toss 2 coins, you have a 50% chance of getting exactly 1 heads. All right, B, getting a 3 when you roll a 6-sided die. So there are 6 outcomes, so that goes in the denominator, one of which involves a 3. The other ones are 1, 2, 4, 5, 6. So the probability is 1 out of 6. All right, dice, cards, coins, marbles. Those are the 4 basic probability things because they're all kind of dealt with random things. So there are 52 cards in a standard deck. If you draw 1 card at random, what's the probability that it's a spade? So we made a list here of all the different cards. There are 13 hearts, 13 diamonds, 13 spades, 13 clubs, goes 2 through 10, jack, queen, king, and an ace. So there are 52. That goes in the denominator. 13 of them involve a spade. So the probability of drawing a spades would be 13 over 52, or 1/4. All right, so the chances of lifetime smokers having a chance in 1 and 2 is 1 out of 2 for dying from a smoking-related disease. Never gonna happen. Probability of winning the odds are 80 million to 1, and they're buying a lottery ticket. So probability shows up kind of everywhere. It does affect our decisions. Okay. Sometimes people don't exactly like it. The probability of somebody watching you is proportional to the stupidity of your actions. The stupider you are, and the more likely somebody's there with a camera to put it on YouTube. This store already had a millionaire, so they're going to go somewhere else. Probability, what's happened in the past, if it's true probability, has no influence on what happens in the future. Okay? So if I've flipped a coin and I've gotten 3 heads in a row, the probability of getting heads the next time is still 1 out of 2. Doesn't matter what has happened in the past, probability is still the same. So this guy used to make an omelet with 4 eggs. 1 in 4 eggs contained salmonella, so now we have 3 egg omelets. It's not exactly how probability works. Okay, probability of each egg having salmonella, still 1 out of 4, doesn't matter how many you put in there. All right, so if you guess a question at random, what's the chance your guess will be correct? It's kind of fun. So 4 answers, you would say 1 out of 4, 25%, except for 25% shows up twice, which would mean 2 out of 4 is 50%. Well, 50% shows up once, so the answer is 1 out of 4, which is 25%, but that shows up twice, so that means the probability of that is 50%, and yeah, you can have fun with that. And the classic marbles, we got 4 white and 3 red. If 2 are selected without random, and students is Professor, what's an urn? So, don't necessarily get caught on what is going on. It's more about math than the wording. All right, so what is the probability that a randomly selected with 3 children has 2 boys and 1 girl? All right, so we are going to make a list. There are 8 different outcomes, from 3 boys to 3 girls, everything in the middle. 2 boys, 1 girl, 2 boys, 2 girls and a boy. Okay, so 8 different outcomes. There are 4 events, but we're worried about outcomes for this one. So 8 goes in the denominator. There are 3 cases where there are 2 boys and a girl. The girl can be the oldest, the girl can be the middle child, or the girl can be the youngest. So the probability would be 3 divided by 8. All right, if you're at a conference and you randomly select a person, what's the probability that their birthday is going to be in July? Now, first thought for some people is going to be, well, there's 12 months, 1 out of 12. Not the case, because not every month has the same number of days. February has 28 or 29, depending on the year. Some months have 30, some months have 31. So it's not as simple as 1 out of 12. But there are 31 days in July, so 31 goes in the numerator. 365 days for the year, so the probability would be 31 divided by 365. M&Ms theoretically have a random distribution of probability, so the probability of getting an orange is the same as red. However, if you've poured out all the M&Ms out of a bag, you've realized that that is probably not the case. All right, so that is theoretical. The other one is relative. Okay, this is an observational one. So it's the number of times that something has occurred divided by the total number of observations. So geological records indicate that a river has flooded 4 times in the last 10,000 or 2,000 years. What's the relative frequency probability that's going to flood next year? So 4 times 2,000, so 4 over 2,000, or 1 out of 500. Now, one of the things you have to watch out for with relative probability is, when did they happen? Okay. If the 4 flood stages have occurred in the last 20 years, That might be something that's very different than if they've occurred, let's say 100 BC or 100 AD, 250, 300 AD, and 1612. I don't know, throughout some years. Okay, that's a very different case where if it hasn't happened in 400 years, probably not going to be too worried about it. Or if one happened in 150, and then we had one in 2001, 2012, 2014. Okay, so when you're dealing with relative, you do need to pay attention to when the events occurred because it will influence them. Probability of a piano falling on the head? 0 at this moment. All right, the last one is subjective. Okay, and this is kind of the stuff you make off the top of your head. So you could estimate the probability the friend will be married within the next year. Okay, it probably depends on whether they're dating someone, if they're living together, if they've got a ring on their finger, or if they're not even dating someone at all. Those are all just kind of probabilities. Okay. The probability, if you want to do a subjective, of driving down Greenville Boulevard and getting all green lights, I'm sure most of you could probably agree that would be close to 0. Okay. There is no theoretical anything we can do. It's really just a subjective probability of what you've experienced. All right, so kind of doing a couple different ones. 7A, 100% happy, you will be happy, 100% certain that you will be happy with this car. That is going to be a subjective. Every salesman is going to tell you that. They're not going to sit there and be like, yeah, I'm 20% sure that you're happy with this car. If they do say that, give them props for being honest and then probably go somewhere else. But that would be a subjective one. All right, based on government data, chances of dying in an automobile accident are 1 in 8,000. That would be a relative. They took the number of deaths divided by the number of people driving. And the probability of rolling a 7 with a 12-sided dice is 1 out of 12. That would be your theoretical. A is more likely. B may want it more, but in math, we just kind of deal with cold hard numbers, so A is more likely to get it, kind of regardless of whatever B wants. All right, counting principle. So if we are interested in how many outcomes there can be, what we're going to do is we're going to multiply it. So that's really everything that this is saying. Okay, so if we look at this example here on the right, for a restaurant, we have 2 appetizers, 5 main course, and 3 choices for dessert. If we're going to pick one of each, how many can we have? Now, one of the important things for these is you can only take one from each category. If you start selecting more than one per category, then you have to do a different method. So we have 2 appetizers, 5 main courses, and 3 desserts. So 2 times 5 times 3 is 30 different meal options. If we have a college that offers 12 natural sciences, 15 social sciences, 10 English, and 8 fine art classes, and you are taking one of each category, we're just going to multiply. So 12 times 15 times 10 times 8 is 14,400 different ways that you can meet those requirements. So don't tell me that there's no class options that you want. All right, so at this restaurant, we have 3 choices for soup, 6 choices for an entree, and 5 desserts. How many 3-course meals can we order? We are just going to multiply. So 3 soups, 6 entrees, and 5 desserts. Multiply them and you get 90. So I saw this on a Wendy's hamburger. There are 256 ways you can personalize a Wendy's hamburger. Just in case you were wondering. All right, so all probabilities have to add up to 1. So sometimes the probability of an event not occurring can be as simple as subtracting the answer of it occurring from 1. So if the question is, what's the probability that a family with 3 children does not have 2 boys and a girl? Well, if you remember from a couple of examples ago, we said the probability that they do have 2 boys and a girl was 3 out of 8. So if the chances of that not happening, we can take 1 minus 3 over 8 and get 5/8. So there's a 5/8 chance that a family with 3 children does not have 2 boys and 1 girl. If you wanted to make a list, you could go back to the list that we had, circle all the ones or check off all the ones where they don't have 2 boys and a girl. In that case, you would still have 5 options, so 5 out of 8. All right, a distribution. This is when we are talking about events. Okay, so tables in these cases will help. So if I want a probability distribution, if we want to know what it is for flipping 2 coins, I have two heads and a tail, 1 head and 1 tail, 0 heads and 2 tails. Those would be my events. Now, there is one way that I can get 2 heads and no tails, so the probability is 1/4 or 25%. There are 2 ways to get 1 heads and 1 tails. I can go heads, tails, I can go tails, heads. So that would be 2 out of 4 or 50%. And I can have 0 heads and 2 tails, goes tails, tails. That is 1 out of 4, so 25%. When I add up all the probabilities, I have to get 100%. So that would be your distribution table. So once again, distribution tables are based on the events. All right, so that's probability. There's also odds. Okay, for those of you that follow sports, you probably hear odds talking about a lot. Okay, so probability versus odds. So what you do is to find the odds of something happen is the probability that it does happen over the probability that it does not happen. Okay. All right, so I want to know what are the odds of rolling a 4 on a 6-sided dice. So the probability of rolling a 4 is 1 out of 6. The probability of not rolling a 4 is 5 out of 6. In every single case, the denominator is going to cancel. So the 6's cancel, and the odds of rolling a 4 are 1 to 5. The flip side of that, the odds against rolling are 4 to 5, or 5 to 1. Okay, the odds of rolling against rolling a 4 are 5 to 1. So if you are following sports, you'll often see, here are the odds of, this team winning the Super Bowl, and they'll say it's 20 to 1 or something like that. Okay. Usually they're done in gambling. Okay. That's what the odds are. It's the probability of something happening divided by the probability of it not happening. All right. So odds are not very good for the kids going to the principal's office. And what happens when a statistician marries a probability expert? I know the odds of that working out. All right, that is it for basic probability, and enjoy.